Hello my dear students. In the today's session we are going to start the chapter electricity. What are the concepts that we are going to study in this chapter? We are going to study here the meaning of electric current and electric circuit and also electrical potential and potential difference. We are going to learn here the Ohm's law and also the resistance and factors affecting resistance. We are going to study the resistance of system of resistors when the resistors are connected in series and when the resistors are connected in parallel. Then we are going to study here the heating effect of electric current. And also we will learn about the practical applications of heating effect of electric current. Then we are going to understand about the electrical power. So these are the concepts that we are going to study here. In the today's session, we shall understand what do we mean by electric current and electric potential. When we say electricity, it is basically the study of charges. What do we mean by electricity? It is study of charges. And we are going to, and in electricity, basically there are two types of study here. One is static electricity, another one is current electricity. Static electricity is also called as electrostatics and current electricity is also referred to as electrodynamics. Static electricity mainly deals with the study of charges at rest. And current electricity or electrodynamics deals with the study of charges in motion. In this particular chapter, we are going to study here the current electricity, where we are going to study the charges in motion. So basically, electricity means it is the study of charges. So how does this idea of existence of the charges came? It was first done by the American scientist, that is Benjamin Franklin. What he done was, he had taken a glass rod and he rubbed that glass rod with a silk cloth. This is a glass rod. He rubbed this glass rod with a piece of silk cloth. He found out there that there is a existence of charges. At that time, the electrons were still not discovered. But he found there is a existence of positive and negative charge there. Actually, what has happened when the glass rod is rubbed with a piece of silk cloth? This is silk cloth. This is glass rod. There was transfer of electrons from glass rod to silk cloth. There was transfer of electrons. When there is transfer of electrons from glass rod to silk cloth, here there is deficiency of electrons. Here there is deficiency of electrons. Whereas in case of silk cloth, the electrons are gained here, because of which there are excess of electrons. This gives rise to the idea of charge, because of which these two are said to be charged, as there is gain and loss of electrons. What happens here? In the case of glass rod, the charge Q is greater than 0. In this case, the charge Q is less than 0. We know that in an atom, we have number of proton equal to number of electrons for a neutral atom. What happens when there is removal of electrons? There is deficiency of electrons, because of which the number of protons will be greater than number of electrons, because of which the Q will be greater than 0. It will be positive because the number of protons are greater here when the electrons are removed. What happens when there is excess of electrons? Here the number of protons will be less than number of electrons. We know that protons are positively charged particles and electrons are negatively charged particles. As there is excess of electrons, the Q will be less than 0. So we say that a body is positively charged when there is loss of electrons or deficiency of electrons. So, when Q is positive, then there is loss of electrons. You have to remember this. When Q is negative, there is excess of electrons or there is gain of electrons. So, Q is negative when there is gain of electrons. You can also write it as deficiency of electrons, or here you can write here excess of electrons. So now we have understood whenever the body is charged, it is either gaining the electrons or losing the electrons. You have to remember the fact that the body will be charged only when there is either gain of electron or loss of electron. You have to remember here one thing that is very important is the charge on the body is due to gain or loss of electrons. Loss of electrons and not due to protons, because protons cannot be removed from the nucleus as they are tightly bound in the nucleus, because nucleus is rigid and dense. The body becomes charged only due to the removal or gain of electrons, not by the change in the number of protons, because proton will be fixed in the nucleus. As it is tightly bound in the nucleus, it cannot be removed. Whenever we talk of the positive and negative charge, we will talk about the excess or deficiency of the electrons only. You have to remember this fact. Yes? Now let us understand some of the properties of charge. Understand here, charge is a scalar quantity, means it has only the magnitude. It has no direction. Charge is scalar quantity, means having only magnitude. And second point is charge can be positive, negative or zero. When the body is said to be positively charged, when there is deficiency of electrons. When the body is said to be negative charged, negatively charged, then there is excess of electrons. So, charge can be positive, negative or zero. So, when we say it is positively charged, when there is deficiency of electrons, and negative when there is excess of electrons. Zero when the number of protons is equal to number of electrons. Next, the SI unit of the charge is coulomb. The SI unit of charge is coulomb and it is denoted by capital C here. There are many other units of charge like millicoulomb, microcoulomb, picocoulomb, nanocoulomb in this way. Where are these used? It will be helpful for you in the solving of numericals. 1 millicoulomb, which is denoted by M capital C, it is equal to 10 raised to minus 3 coulomb. And 1 microcoulomb is equal to, it is denoted by mu capital C, is equal to 10 raised to minus 6 coulomb. In this way. Next is principle of quantization. Principle of quantization of charge. What it says? It says that any physically existing charge Q, it is an integral multiple of elementary charge or fundamental charge. What do we mean by elementary or fundamental charge? It is equal to the charge on electron or proton. It says that any physically existing charge Q is equal to, it is equal to the integral multiple of elementary charge or fundamental charge. And this elementary charge or fundamental charge means it is equal to the charge on electron, which is equal to charge on proton, equal to plus or minus E. The charge on electron and charge on proton are same in the magnitude. Only the difference is they have opposite charges. The principle of quantization of charge says that the value of charge, it is equal to the integral multiple of elementary charge or fundamental charge. So it is given by Q is equal to plus or minus NE, where N is any positive integer. So the value of charge, it is equal to the integral multiple of elementary charge or fundamental charge. Q is positive when there is loss of electrons or deficiency of electrons. When there is loss of electrons or deficiency of electrons. Q is negative when there is excess of electrons or gain of electrons. Excess of electrons. The next property is the charge on the particle is independent of the speed of the particle. The charge of the particle is independent of the speed of the particle. For example, if the charge is at rest, then it will have the same charge as that of the charge if it is in motion. This charge, when it is at rest, has the same value, and also when it is in motion, then also it will be having the same value. Now let us solve some of the numericals. First one, how many electrons makes 1 coulomb of charge? It is important. So now we have learned that according to the principle of quantization, the value of charge is given by Q is equal to plus or minus Ne. Here the charge is positive, that is 1 coulomb. So we can take Q is equal to Ne. We have to find here the number of electrons. They have asked the number of electrons which makes 1 coulomb of charge. So first let us write the given quantities here. First, let us write the given quantities here. What is given here? Charge Q is equal to 1 coulomb. Sometimes charge is denoted by capital Q. Sometimes it is also denoted by small q. Okay. Then we know that Q is equal to plus or minus Ne. Here it is plus 1 coulomb. So let's write here Q is equal to Ne. Given Q is equal to 1 coulomb. Now we have to find out this N. That is the number of electrons which makes 1 coulomb of charge. So N is given by Q upon E, which is equal to 1 coulomb by, what is the charge on the electron? We know 1.6 into 10 raised to minus 19 coulomb. So what we are going to get here? 1 upon 1.6 into 10 raised to 19, which is equal to 10 by 1.6 into 10 raised to 18. This can be written as 10 into 10 raised to 18 also. This 10 raised to 19 can be written as 10 into 10 raised to 18. So it will be easier for calculation. If you remove the decimal here, it is very easy to calculate the answer. So I will write it as 100 by 16 into 10 raised to 18, which is equal to 6.25 into 10 raised to 18. So we have got here the number of electrons which makes 1 coulomb of charge is 6.25 into 10 raised to 18. So the number of electrons which makes 1 coulomb of charge is equal to 6.25 into 10 raised to 18 electrons. So if anybody asks you what are the number of electrons which are contained in 1 coulomb of charge, then you have to say that 6.25 into 10 raised to 18 electrons. Let's solve one more question here. A polythene piece has 10 raised to 9 excess electrons. Then find the nature and charge on it. We have to solve this. First, let us write the given quantities. Given the number of electrons is equal to n is equal to 10 raised to 9. As there are excess electrons, Q is equal to minus Ne. We have Q is equal to minus Ne because there are excess electrons. So let's find here the charge. Q is equal to minus 10 raised to 9 into magnitude of charge on the electron, it is equal to 1.6 into 10 raised to minus 19 coulomb. So Q is equal to minus 1.6 into 10 raised to minus 10 coulomb. This is the charge on the polythene piece. And they have asked to find out the nature. As there are excess electrons, the nature of polythene piece is negative. Means it is negatively charged. So we have find out the charge and the nature of the polythene piece here. Now we are going to study about the electric current. What do we mean by the term current? It means flow. Whenever the water flows, we refer it to as current of water. Whenever the wind flows, we refer it to as wind current. In the same way, electric current means it is the flow of charges. We define it as rate of flow of charges with respect to time. So, it is rate of flow of charges with respect to time. And it is given the symbol I, or sometimes small I is also used. So, electric current is equal to electric charge upon time. So, I is equal to Q upon T. What is the SI unit of this electric current? Let's see here. SI unit of electric current. It is equal to SI unit of charge by SI unit of time. So SI unit of charge is coulomb. SI unit of time is second. So it is equal to coulomb per second. And in the honor of the scientist named Andre Marie Ampere, this SI unit of electric current is given the name ampere. So it is equal to ampere. The SI unit of electric current is given the name ampere, and it is given the symbol A. So you have to remember here, electric current is the rate of flow of charges with respect to time, and you have to remember this formula. This is very important. You will get numericals based on this formula. This is the formula for electric current, which is equal to Q upon T. And from this formula, you can also calculate the charge also. Q is equal to I into T. Sometimes charge may be given and you are asked to calculate the electric current. And sometimes electric current may be given and you are asked to calculate the charge. That is electric charge. So you have to remember this formula. Now we know that SI unit of electric current is ampere. So what do we mean by 1 ampere? Let's see here. 1 ampere, it is equal to 1 coulomb of charge flowing per second. When 1 coulomb of charge flows through a conductor per second, then the electric current flowing is said to be 1 ampere. So, if a charge of 1 ampere flows through a conductor in 1 second, then electric current is said to be 1 ampere. What if I say 15 ampere of current is flowing? It means 15 coulomb of charge is flowing. It means 15 coulomb of charge is flowing in 1 second. If I say 30 ampere, then 30 coulomb of charge is flowing through the conductor in 1 second. This is how we will define 1 ampere. Here, the meaning of 1 ampere is, we know that we have calculated few minutes before, we have calculated the number of electrons in 1 coulomb of charge. What is that number? Yes, exactly. It is 6.25 into 10 raised to 18 electrons. Hence, if 6.25 into 10 raised to 18 electrons flows through a conductor in 1 second, then current is said to be 1 ampere. We should also have knowledge of some other units of electric current. Like, take it as a note. If I say 1 milliampere, it is equal to 10 raised to minus 3 ampere. These points are useful in solving the numericals. If I say 1 microampere, milliampere is denoted by MA and this is denoted by mu A, which is equal to 10 raised to minus 6 ampere. If I say 1 nanoampere, then it is equal to 10 raised to minus 9 ampere. So you should have some knowledge regarding other units of electric current also. These are called as side prefixes. Yes. Now let's see about the direction of electric current. The direction of electric current is opposite to the flow of negative charges, that is electrons. The direction of electric current is opposite to the flow of electrons. Initially, even before the discovery of electrons, the electric current was known. At that time, it was assumed that the electric current is due to the flow of positive charges. So they have taken at that time the direction of electric current as along the direction of flow of positive charges. But today we know that the flow of electrons constitute the electric current. Conventionally, this direction of electric current is taken as opposite to the flow of electrons. For example, if this is a conductor, the electrons are flowing in this direction. Now the direction of current is said to be B to A. Flow of electrons from A to B. If anybody asks you what is the direction of electric current here, we have to say the direction of electric current is B to A, because the direction of electric current is opposite to the direction of flow of electrons. So, direction of electric current, it is from B to A. Then how do we measure the amount of current flowing through a circuit? It is by the device called as ammeter. Ammeter is used to measure electric current. And it is given by the symbol positive terminal and this is negative terminal. You have to note here 2 points about the electric current. Note number 1. At any junction, the net inward current is equal to net outward current. For example, here, this is the junction where I1, I2, I3 are flowing through this junction. This is I1, I2, I3. These currents are flowing towards the junction and I4, I5 are the currents which are flowing away from the junction. Means these two are outward current, these three are inward current. Now the net inward current is equal to net outward current, which means I1 plus I2 plus I3, it is equal to I4 plus I5. These three are inward current, which means they are flowing towards the junction, and these two currents are flowing away from the junction. Hence, at any junction, the net inward current is equal to net outward current. At any junction, the net inward current is equal to net outward current. One more thing here. The electric current passing through a conductor is independent of the area of cross section. The electric current flowing through a conductor is independent of area of cross section of the conductor. Suppose this is a conductor in this way. Suppose for this part I1 is the current flowing through this part of the conductor and I2 is the current flowing through this part of the conductor and I3 is the current flowing through this part of the conductor. Now the electric current flowing through this conductor is independent of the area of cross section, which says that I1 is equal to I2 is equal to I3. And also remember here, electric current is a scalar quantity. Even though it has a direction, it is a scalar quantity. Because of which the net current which is flowing towards the junction, it is equal to the net current which is going outwards. Now we are going to understand about the electric potential and potential difference. Electric potential and potential difference. First, let us understand some of the examples here before going to understand about the potential difference. See here, whenever a metal rod is heated, this is a metal rod AB. This is heated at the point B. Heat will flow from the point B to A also. It is because of the temperature difference between the 2 points. If there is no temperature difference between these 2 points, then the heat would have not flowed. Again, see here, if this is a water pipe and it is kept horizontal, you take water in it, whether the water flows, actually the water will not flow because there is no pressure difference for the water to flow. Again, what I do is, I will take a tub and fill it with water. If I make a hole here and connect a pipe and place another tub on the ground, what happens here? Now the water will flow through the pipe. When the water was taken in the horizontal pipe, the water was not flowing. Now what's happening here? The water is flowing from the tub which is kept at some height into the tub which is placed on the ground here. Why the water is flowing now? Because of the difference in height. Because here difference in height. So water will flow when there is difference in height due to gravity. Here the temperature difference will cause the heat to flow from B to A. This shows that there must be temperature difference for flow of heat and there must be height difference for flow of water. In the same way, for the electric current to flow, we need potential difference. This is the electric pressure which we require in order to cause the flow of electric current. Suppose I take a metallic wire here. It contains large number of free electrons. And these electrons are moving randomly in any direction. There is no specific direction for the electrons to move here. They are moving randomly in all the possible direction, because of which the net motion of the electrons will be zero. The net motion of electrons is zero. But now what happens if I connect this metallic wire to a battery? Then there is a flow of electric current. Why does this happen? Because the battery is responsible or the cell is responsible for the electron to move in a particular direction. Because the battery or cell is spending energy in setting these electrons in motion. So in order to flow the electric current, we need some energy. The work is need to be done. What the battery or cell is doing now? Suppose if you connect this wire to a battery or a cell. Now all these electrons will start moving in a particular direction continuously. This is because of the fact that this battery or cell is spending the energy. It is doing work. The chemical energy which is stored in the cell is converted into electrical energy. And that work is done in order to set these charges in motion. Now the charges will be start moving. Because of that, the current will flow through this circuit. Now we can define the potential difference. What do we mean by potential difference? It is the work done. It is defined as work done in moving unit positive charge from one point to another. So now we have understood that work is need to be done in order to cause the flow of electric current, so that it will create the potential difference and cause the electric current to flow. Now we define electric potential as it is the amount of work done in moving unit positive charge from infinity to any particular point. Suppose the charge is at infinity, means it is at any unknown point, and we need to bring this charge to the point A. So the work done in moving this charge from infinity to this point, it is called as electrical potential. Then what is the potential difference between 2 points? The potential difference between the 2 points is defined as the amount of work done in moving a unit positive charge from one point to another. So it is the amount of work done in moving unit positive charge from one point to another. And this potential difference is denoted by the symbol V. Now the potential difference V is equal to work done by charge. Suppose these are the 2 points A and B and the charge is placed here. Now the amount of work done in moving this charge from this point to this point is called as potential difference between these 2 points. It is the amount of work done in moving this charge from here to here. It is called as potential difference. What is the symbol for work done? W. And what is the symbol for charge? It is Q. So V is equal to W by Q. You have to remember this formula, which is very helpful in solving the numericals. And also the SI unit of potential difference, it is equal to SI unit of work, that is joule, per SI unit of charge, that is coulomb. And this SI unit of potential difference, joule per coulomb, is given the name as volt in the name of the Italian physicist Alessandro Volta. So SI unit of potential difference is equal to volt. Now let's define here the meaning of 1 volt. The potential difference between 2 points in a current carrying conductor is said to be 1 volt when 1 joule of work is done in moving 1 coulomb of charge from one point to another point. In moving 1 coulomb of charge from one point to another. So 1 volt is equal to when 1 joule of work is done in moving 1 coulomb of charge from one point to another point. So let's recall about the electric potential and potential difference here. What do we mean by electric potential at a point? When we move a unit positive charge from infinity to that point, the amount of work done, it is called as electric potential. And what do we mean by potential difference? It is the amount of work done in moving unit positive charge from one point to another. The amount of work done in moving this unit positive charge from this point to this point, it is called as potential difference between these 2 points. And it is given by V is equal to W by Q. And SI unit of potential difference is volt. Then how do we define 1 volt? It is the amount of work done. Then how do we define 1 volt? When 1 joule of work is done in moving 1 coulomb of charge from one point to another. Now the instrument which is used to measure the potential difference is called as voltmeter. The instrument used to measure potential difference is called voltmeter. And remember here, always the voltmeter is connected in parallel across the points between which the potential difference is need to be measured. For example, suppose here if you want to measure the potential difference between these 2 points, then the voltmeter is always connected in parallel across these points. And in case of ammeter, it is always connected in series in the circuit. In case of ammeter, suppose this is a circuit, it is always connected in series because the same current will flow through this ammeter if it is connected in series. If you connect it in the parallel, what happens? The current will get divided. So if we want to measure the current through the circuit, we will always connect it in the series in the circuit. So note here, the voltmeter is always connected in parallel across the points between which the potential difference is to be measured. See here, we want to measure the potential difference between A and B. Then we will connect the voltmeter parallel across these points. Let us solve some numericals here. Question number 1. If a charge of 2 millicoulomb flows in a conductor for 4 seconds, then find electric current. Now first let us write the given quantities here. Read the question properly. If a charge of 2 millicoulomb flows in a conductor for 4 seconds, then find electric current. We have to find out the electric current flowing here. Given charge Q is equal to 2 millicoulomb, which is equal to 2 into 10 raised to minus 3 coulomb. We have to convert it into coulombs. Then time given is 4 seconds. We have to find out here the current. We know the formula as I is equal to Q upon T. Q is 2 into 10 raised to minus 3 coulomb and T is 4 seconds. So it is equal to 0.5 into 10 raised to minus 3 coulomb per second or 0.5 milliampere. So current flowing through this is 0.5 milliampere. You can also write it as 0.5 into 10 raised to minus 3 ampere. Let's try next question. The potential at a point is 10 volt. Find amount of work done in bringing plus 5 coulomb charge from infinity to that point. Yes, what they have asked here. The potential at a point is 10 volt. Find amount of work done in bringing 5 coulomb of charge from infinity to that point. Let's write the given quantities first. Given potential at a point Let's take it as VA. Potential at the point A. It is equal to 10 volt. Then charge, it is given plus 5 coulomb. What we have to find? The amount of work done in bringing the charge from infinity to that point. That is, we have taken it as A. We know the formula. Potential at a point is given by work done in moving the charge from infinity to that point divided by charge. So we have to calculate here work done. It is equal to potential at that point into charge. 10 joule per coulomb. What is the charge? 5 coulomb. So we will get 10 5s are 50 joules. So we will get 50 joules. These two will get cancelled. So the work done is equal to 50 joules. What is this work done? It is the work done in moving the 5 coulomb of charge from infinity to the point A. In order to bring this 5 coulomb of charge from infinity to the point A, we are doing here 50 joules of work.